All right, we're going to do here exercises from the binomial distribution. And this is problem number 3. A box contains 3 blue marbles and 5 red marbles. Marbles are drawn at random with replacement n equals 8 times. A. Draw a box model. So what I'm going to do is draw a picture of something that looks sort of like a box, and I'm going to write 3B for 3 blue, 5R for 5 red, and that does the job. Okay, I might just add, if I write, no, okay, I won't do that yet. Okay, B. What is the probability of drawing in this order blue, red, red, blue, red, blue, red, blue. Okay, so this is probability of B, R, R, B, R, B, R, B. Okay, now let's just notice that what we're doing is, first of all, are there 8 of these? 1, 2, 3, 4, 5, 6, 7, 8. Okay, what we're doing is we have this one event, and this is all the outcomes. And so what we're going to do is we're going to think of this as drawing one marble and finding that probability, and then drawing another marble. And so when you say, let's just talk about drawing 2 marbles. What you can do is you can multiply the probability of getting the first marble times the probability of the second drawing of getting that red. So if you have 2 successive things that are happening, you multiply the probabilities. Now, the box does not change each time because we're replacing the marbles after we draw them. Now, for this problem, the probability of drawing a blue is 3 blue marbles out of 8 in total. Then for red, we have 5 red out of 8. So the probability of blue is not the same as probability of red, unlike tossing a fair coin. So I'm just replacing probability blue by 3/8, probability red by 5/8. And there's a lot of numbers here, so it would be right up my alley to get this mixed up. 1, 2, 3, 4, 5, 6, 7, 8. So what we see is that we have how many blues? Well, 1, 2, 3, 4. So it's 3/4 or 3/8 raised to the 4th power, because we're multiplying 3/8 by itself 4 times, and then there's 5/8, and there's 4 of those. Well, I mean, without a calculator, this is a sort of a lot of trouble. I don't know, yeah, a little bit of trouble. I mean, I can do it, I think, but you have the calculator, so, you know, why not use that? Okay, sometimes I don't feel like using the calculator because it's just easier to do it by hand, but this one I just feel like, well, maybe I'll use the calculator. And even when I use the calculator, I'm not really all that confident I'm going to get this right. So I get this as 0.030174851, and then there's a button on the calculator that will actually put that as a fraction if we want. Oh no, this calculator doesn't, for this number it doesn't, it's too big of a number. 8 to the 8th power is a pretty big number. 8 to the 8th power is, yeah, doing this by hand would have been a lot. 16,777,216 is 8 to the 8th power. So that would be a challenge without a calculator. Okay, so let's see. Let x be the number of blue marbles drawn out of n equals 8 drawings. X has a binomial distribution. So x is a random variable, and it has a distribution which is a binomial distribution. And one way you can think of that distribution is by the graph that we'll draw. Okay, so we can use, but maybe we won't. I mean, actually, I know I won't. Probability x equals k, like x equals 2, x equals 3 is n choose k, p to the k, 1 minus p to the k, where p equals 3/8 is the probability of drawing blue on one trial, on one drawing. Each time you draw, that's called a trial. Okay, but we can also use the TI-83 calculator. It's like a little advertisement for that calculator. And second distribution 0 binom PDF, and then you enter that, and then you get binom PDF, and you put 3 numbers in, and you have to put them in this order: N, P, and K. So if you don't get that order, then it's not right, and then you have to play around and try to get the right order. You'll just get error. So so that's what I'm going to use, is the calculator. In other videos, I explained that formula. I went through it sort of quickly, but still, I did do that. Okay, so we're going to find probability x equals 0. And so I'm going to use this binom PDF. And how do I get there again? I'm not going to write each time, but I just wrote it down a moment ago. Okay, and then I'm going to put in 8, because that's n. What? I just forgot. How many? There's 3 out of 8 marbles are blue. That's P. And then I want to do 0 is the number we're looking at. Okay, so what does this means? This is the probability of drawing 0 blues, which is the same as 8 reds. Okay, so you punch that in there, and if you do it often, then it starts going a little faster. You start getting a little bit used to these. Okay, I got 0.232830644. Now I'm going to go on to probability x equals 1, and you can just type in all this stuff, but you can also type in second entry, and then it's going to bring up, once again, this binomial PDF, but it's going to bring up what was the last entry. And so it'll bring up the last entry, and then what I do is I edit it to make this 8381. So you edit this. So I went into a little more detail in the last video how you did that. That was the tossing the coin video. And you just keep doing all this. Okay, this is sort of dangerous. I'm putting down all these things before I work them out, so maybe I won't have enough space, but I think I will. So I'm just going to write here, this will be binomial PDF 8382. See, I think I might not have enough space there. So that's 0.23469 dot dot dot. And so this, I'm going to keep doing all this, and this is 0.2816319466. Oh gosh, well, I mean, how many places do we need to write this out? So this one's less than 1% chance of happening. Okay, let's look at this one. It's not like it's super interesting, but it has something going on here. This says e to the minus 4. That's what it says on the calculator, e minus 4. What this means is this is 3.9 around times 10 to the minus 4. So what does that mean when you have 10 to, that's what e minus 4 means, and you should write it this way, 10 to the minus 4. That means I take this 3.9 and I move the decimal 1, 2, 3, 4 places to the left. And that's what that means. So that's, you know, that's 3/100ths of 1%. So that's sort of small. Okay, so you're very unlikely to get 8 blues. Extremely unlikely. If you can do that, then maybe you should, maybe you have magical powers and you can make lots of money in Las Vegas or something. But okay, so we're going to sketch. That's part 2 of A. Sketch the probability histogram. It's called a probability histogram because these are probabilities. So a histogram based on an experiment would be the outcomes, and you make like a bar graph of the outcomes from the experiment. So this is what our predictions are through probability. Okay, and so I'm making, it's basically a bar graph, right? So because these are discrete outcomes, I am going to make a bar for each outcome, and I'm going to place the number 0, 1, 2, 3. Those are the number of blues drawn. Out of n equals 8 drawings. So I'm going to do that, and I'm going to place those right in the middle of the bar, and then I'm going to write this in terms of percents. Okay, so I have to go back over here again. So what happened to 0? Okay, so 0 was around 2.3%. So I'm going to Actually, I don't even want to do that. I just want to do it to the percent. Okay, so I'm going to do this. 1 was 11%, and then 3 was 23% around. So I'm rounding these. 28%, 21%. Okay, so I just go through and I round these. So this is, it's not like really a rule. But if I can't, I don't want to round to 0. Well, this is 1%. This was a 0.5%. It's around 1%, and this is close to 0%. Yeah, okay, so I did everything to the full percent, just to the 1%. Okay, so the highest one apparently is 23%. And so then I need to sort of make a decision on how much each of these will count. Okay, so here I'm going to, I guess I'm going to count them 2 each. Maybe not the very best way, but anyway. 2, 4, 6, 8, that's 10%. 12, 14, 16, 18, 20, 22, 24. So I don't think this is like the only way or even the best way, but I had to make a choice. Okay, so this is percent per outcome. So a lot of times when we do distributions, probability distributions, especially if it's not a discrete random variable, if it's a continuous random variable, you would do percents per standard deviation. Just thought I'd throw that in there, but that's not really all that clear what I just said without doing more explanation. All right, so I'd say there is also a fairly high probability that I'll make a mistake doing this somehow. I'll just draw it and then I'll just end up making a mess of it, but I'll still do it anyway. I don't think at this point I've already committed to this video, so I don't think I'm gonna throw it away, even if I make a mistake. I'll just write over it. Oh, hold on, 26, 28, 30. Okay, so 3 is 28%. And 4 is 21%. I don't know, it's sort of fun doing these drawings, but there's computers that'll make it look way nicer. I don't think I would turn this in if I had a project to show for a bunch of people. Okay, so here's my lovely curve. And so part 3, describe the graph. I would say it is almost symmetric. It is approximately bell-shaped, but not really that. It's a little bit off. And the reason why it's not exactly bell-shaped, like for example when you toss a coin, is because the probability of the blue was 3/8 and the probability of the red was 5/8. And so therefore you see this sort of situation where it's a little bit skewed right. But still, it's sort of normal distribution. And if we don't have that many numbers here, but if you toss the coin about, say 1,000 times, it would not be entirely symmetric, but it might be close enough so we could use, say, the empirical rule. Okay, so then number 4, shade in the region x is between, no, x is greater or equal to 4. So that means that, including 4, so that means this is the situation where you have 4, 5, 6, 7, or 8 blues. Huh, well, for whatever reason, I decided to use a red pen for that, or red crayon. Maybe because I can't find a blue crayon, but anyway. And by the way, why don't I go ahead and write down the probabilities here? So this is approximately 2%, 11%, 23%, 28%, 21%, 10%, 3%, 1%, and then about 0%. But this one we should note is actually not really a very high-tech operation here, but anyway, this is not really 0%. It's 0.03%. Okay, so these should add up to 100%. I mean, there's rounding, so maybe it's a problem if we took the time to really look at that. But it rounds up to 100% around, close to it. Okay, so I shaded in 4, 5, 6, 7. And what happens is each of these areas correspond to a probability, and the total area under the curve is 100% or 1. So we're going to find the probability that we get 4 or more blues when we draw 8 times. Well, this is the probability of probability x equals 4 plus probability x equals 5 plus probability x equals 6 plus probability x equals 7 plus probability x equals 8. And this is going to be 21% plus 10% plus 3% plus 1%. And this is not equals, it's approximately equal, plus 0%. And then there's a question whether it's worth my trouble to take the calculator out or do it in my head. 21 plus 10 is 31, plus 3 is 35%. So, could be, but it might be worthwhile to double check. 1 plus 3 is 4, plus 10 is 14, 15, 35%, yeah. Okay, so anything else? That's all.